Working with solving polynomial equations. We have been solving polynomial equations before now, and that was when we were doing quadratic equations and we would solve them. And what we're going to do now is we're going to look at higher order polynomials, and we are going to be finding more than just those two solutions or possible two solutions that we were doing before. One thing that we are going to introduce here is going to be our sum of cubes and our difference of cubes. Very similar when we had the difference of squares, and of course we did learn later on the sum of squares. So again, we're just dealing with cubes, so we have three possible roots, and we will go into a couple of examples here, and of course that's just foreshadowing for what's to come when it comes to the cubes. Looking here, and we take solving polynomial equations by factoring, and then what are the real or imaginary solutions of each one of these. So as we get into these, we can look here and say I have x squared minus 1 times x squared plus 4. Hopefully you can recognize that as the difference of squares, and if we quickly know the difference of squares is going to factor to x minus 1, x plus 1. And then, of course, this is, if you can't recognize it, we'll just keep it the same for now. Now, I know that I've already got this portion over to the left. I'm factored here as much as I can. Those are my prime factors. And if I come here and I look for the factors of the sum of squares, we should recognize that then as x, it's going to be x plus 2i or x minus 2i, and we did that just a few weeks ago when we were dealing with solving quadratics right before the quadratic formula. So there we go. We have factored these two quadratics into x minus 1, x plus 1, x plus 2i, x minus 2i. And of course, to do our solutions, we have x minus 1 equals 0. And taking those, we end up having 4 possible roots, and go ahead and make each one of those prime factors equal to 0 and solve. So as I go ahead and solve those, I have x equals 1 or x equals negative 1, also known as x equals plus or minus 1. And then I have x equals negative 2i or positive 2i, which is also can be written as x equals plus or minus 2i. And those are going to be this is two real solutions, and we are going to have two imaginary, if you don't remember, imaginary solutions for that polynomial. Going forward here, now simply looking at this x to the 5th plus 4x to the 3rd equals 5x to the 4th minus 2x to the 3rd. We need to get this to some form of standard form and get it equal to 0 so we can go ahead and solve. And in doing so, we simply do some inverse operations to get everything, and I'm going to move everything over to the left. So if I subtract 5x to the 4th and I add 2x to the 3rd, that's going to cancel this side out and make it equal to 0. But if I do that to one side, I of course have to subtract 5x to the 4th and add 2x to the 3rd to this side. And in doing so, I end up with, of course, my right-hand side is going to be equal to 0, and the left-hand side, we are going to have 4 plus 2 is going to be 6x to the 3rd. Then I'm going to have negative 5x to the 4th, and of course x to the 5th. And let's see, what can we do from there? I'm going to first and foremost look for a greatest common factor. Hopefully you guys can get that. And now I go ahead, I've taken out my greatest common factor, and that is simply that each one of my terms is divisible by x to the third. And so that's my greatest common factor. Pull that out. That leaves behind. So if I pull x to the third out, that leaves behind x squared minus 5x plus 6. Now I'm going to factor this trinomial, and I'm going to keep x to the third, and then of course this is a easily factored quadratic, and I am looking for factors of 6 that are going to add up to give me -5, and hopefully you've come up with, well, I guess I could do this for you. Factors of 6 that are going to give me -5. Well, we know it's not 1 and 6. We know it's not -1 and -6, but it could be -2 times -3 is going to add up to give me 6, and it is also going to combine or sum to give me -5. So -2, -3 equals 0. Go ahead and do my zero product property. And from here, we do one-step equations and solve. So our solutions there are x equals 0, x equals 2, and x equals 3. And we can go on to the next example here. So we have x to the fourth. Some of you may want to find the square root, but I'm going to encourage you, if I have x to the fourth, why wouldn't I take the fourth root to isolate x? So if I have x to the fourth, I know that if I take the fourth root of x to the fourth, I'm just going to have x left over, and that is going to give me, well, here I need to think about what number multiplied times itself 4 times will give me 16, and I know that 2 times 2 times 2 times 2 is going to give me 16. So one of those answers is going to be 2, and also you have to remember that -2 times -2 times -2, and again -2 is also going to give me a positive 16. So the solutions to x to the fourth equals 16 is going to be x equals plus or minus 2. So continuing with factoring and this cubic equation, of course I've commented I want to get everything equal over onto the left-hand side. And of course here what I've done is I've gone ahead and done my inverse operations, and I end up with, I go ahead and get it into standard form of x cubed plus 2x squared minus 8x equals 0. And as before, we want to go ahead and factor out our greatest common factor. And in doing so, I have x equal, or x times x squared plus 2x minus 8. And I'm not sure, yeah, it should be factorable. In this case, I am looking to factor this trinomial, this quadratic, and since my a is equal to 1, I can go ahead and factor, splitting up my x's, and I'm looking for factors of -8 that will add up to be 2, and that should be a positive 2, -4. That's going to give me -2, so that's not it. Let's go with a -2 and a positive 4. That's going to give me a positive 2, so that's going to be the factors I want. -2, positive 4. Now you can do your zero product property. And doing your zero product property, you're going to have x equals 0, x equals 2, and x equals -4. And those are going to be your real solutions to that cubic function. Okay, so we have example E here. And what I'm going to do is, I'm not sure if it's going to be a waste of my time or not, but I'm going to go ahead and distribute everything and combine like terms, because I need to make sure that I do my multiplication before I do my division. So I'm going to go ahead and do my distributive property and combine like terms and get everything to the left-hand side of the equation. Okay, so I've gone ahead and I've done my distributive property, and I have subtracted 8x plus, oops, 1 second, that seems to be a tiny bit of a mistake, and hopefully you guys caught that. So this would be 8x plus 8, and then I guess never mind. I'm mistaken. So in doing so, now we have left over, this is going to zero out, this is going to zero out, and I'm going to have x cubed equal, or x cubed minus 8 equals 0. And before, at the beginning of the lesson, we talked about the difference of cubes. Well, this can be rewritten as the difference of cubes. So let's see here. I'm going to go ahead and write the rule for the difference of cubes here. So the difference of cubes is going to be a cubed minus b cubed, and then the factored form is going to be this right here, a minus b times a squared plus ab plus b squared. Hopefully you can recognize that a is going to be equal to x and b is going to be equal to 2. And we're going to do some substitution. So that is going to be, it is going to be x minus, again, substituting x minus 2 times a squared, which we see is x squared, plus a times b, which is a times b, plus b squared, which is going to be, b squared is going to be 2 squared, or in this case, 4. And that right there should be the factored form of this thing right here. So again, we recognized it as the difference of cubes and was able to factor it in that manner. And let's see here, going to our next example, we're going to talk about what are the real or imaginary solutions to this. And the first thing I want to do is go ahead and get it written over into standard form, again descending variables all on the left hand side. And remembering here, I've gone ahead and rewritten it. I've subtracted 4x from both sides, so I have 4x cubed minus 6x squared minus 4x equals 0. Hopefully you guys recognize there is a greatest common factor, and we have a greatest number and a greatest variable in common. The variable is going to be 1x, and we're going to have 2 is going to be my other greatest common factor. Factoring those out, I should have 2x squared minus 3x minus 2 is what is left behind. And I'm not 100% sure yet if there's anything that can be done here for factoring this trinomial. And I know that I'm going to have negative 4, and I think we might be able to factor by grouping. So a times c is going to be negative 2 times 2, which is going to give me a negative 4, and then I'm going to go backwards from factoring by grouping here. So I'm looking for factors of negative 4 that will add up to be negative 3, and of course I should have 1 and negative 4. That's going to give me negative 3. So, all right, so factoring by grouping, I go ahead and go from 3 to 4 terms. I'm going to group my first 2 terms, my second 2 terms, find the greatest common factor again, which out of my first 2 terms happens to be x, and that will leave behind 2x plus 1, and again, factoring by grouping should have been done correctly, 2x plus 1. And in order to figure out what the heck am I factoring out right here, I need to take negative 2 and divide it by 1, which gives me negative 2. And so that should be my factoring by grouping, and you can check it. We have negative 2 times 2x is negative 4, negative 2 times 1 is negative 2. All right, so let's see here, 2x times x minus 2 and 2x plus 1 equals 0. Now we can just use our zero product property to come up with the rest. Okay, so doing my zero product property, I have 2x equals 0, or again, x equals 0. Then I have inverse operations there. I have x equals 2, and then again, 2-step equation there, minus 1 from each side, and then divide by the coefficient. So I have x equals negative 1/2. So there are my three possible solutions. And that puts an end to 5.3, solving polynomial equations. And just remind you that you do have some Frere models here that we're going to be doing with this unit. And I will go ahead and do a couple of examples for you on a different video.